Welcome back. In the second part of this section, we're going to now look at some applications of these identities. We've already done that to an extent at the very beginning when we found cosine of 15 degrees, but now we're going to see some other uses of these angle sum and angle difference identities. So here, the question that I have is I want to find the exact value of cosine of theta minus pi over 3. So if we're just sort of strategically thinking here, I know that at some point I'm going to need to use my identity, that cosine of theta minus pi over 3 is cosine of theta, cosine of pi over 3, plus sine of theta, and sine of pi over 3. As far as the things that we know, I mean, we can use special triangles to figure out sine and cosine of pi over 3. That's easy enough. And sine of theta, we were given that in the question. We're told sine of theta is 1/3. The only thing that I need to figure out is this. What is cosine of theta? Once I know that, then I'll have all four parts, and then I can use my cosine of theta minus pi over 3. I can use my identity to figure out what that is. So I guess my first job is figuring out what is cosine of theta, and that's very much a chapter 7 kind of a question. We're told we've got an angle in quadrant 2, so I guess I'll draw that. There's my angle in quadrant 2. And I know that sine of theta is 1/3, and sine is y over r. So that means I should be taking my y value as positive 1 for this point that I have on my terminal side. Mystery x value yet to be determined, and I know that r is 3. So we'll go ahead and solve for what r is. We'll solve for what x is, rather. We know what r is. Using the formula r is x squared plus y squared. So y is 1, so y squared is also 1. Squaring both sides. And then thinking about now looking at x squared being 8, I know where I am. I'm in quadrant 2, and there my x values should be negative, so that means I should be taking the negative square root for 8. And 8 is 4 times 2, so a square root of 8 is a square root of 4 times square root of 2, or negative 2 root 2. And so now I can say what cosine of theta is. Cosine of theta is x over r. That's negative 2 root 2 over 3. Okay, so now we've done our little background work here. We're ready to answer the real question, which is we wanted to know what is cosine of theta minus pi over 3. And we said that we were going to use our angle difference identity for cosine. That's cosine of the first angle, cosine of the second, plus sine of the first angle, sine of the second, and we know all four things. Cosine of theta is negative 2 root 2 over 3. Cosine of pi over 3 is a half. Sine of theta, in the story it said it was 1/3. And sine of pi over 3 is root 3 over 2. And then the only thing left to do here is just a little bit of simplifying, and then we're finished. So I have negative 2 root 2 over 6 and plus root 3 over 6, which if I wanted to combine it into one fraction would be negative 2 root 2 plus root 3 all over 6. And there we go. We found our exact value of cosine of theta minus pi over 3. One thing that's kind of nice to note here, we never actually needed to figure out what is theta. How big of an angle is it? All we needed to know was that it was in quadrant 2, and once we knew the value of sine, we used that to find the value of cosine. And then once we had that, we were able to find cosine of theta minus pi over 3. Just lovely. Okay, so second question, we've got two angles that are both in quadrant 1, angle alpha and angle beta. We're given values for sine, sine of alpha and cosine of beta, and what we want to know is what is the value of tangent of alpha plus beta. So if we're remembering our formula for tangent of alpha plus beta, that formula involved only tangents. And so we're kind of at a crossroads here because we only have sine and cosine, so we know that there's going to be a lot more work left to be done before we can get to applying this formula. I know that I'm going to need to figure out what is tangent of alpha and what is tangent of beta. And right now, all I know is what is sine and cosine of alpha and of beta. And of course, the strategy here is once I know what sine of alpha is, I'm going to use that to find cosine of alpha. And then sine alpha and cosine of alpha, I'll put them together to find tangent of alpha. I'm going to do the same thing for beta. So I'm just going to add another page because I have a feeling this is going to take a little bit longer than just one little sheet. So there we go. And let's get ourselves started with the background stuff. So the background stuff being coming up with what is what is tangent of alpha and what is tangent of beta. So let's start with this. I know for sine of alpha that it's 3/5. And I need to know what is cosine of alpha, and so I'm going to use my Pythagorean identity here. I know that sine squared plus cosine squared is 1. And I know what alpha is, sine of alpha is, it's 3/5. So I'm just going to do this to solve for cosine squared alpha. Bringing the 9/25 to the other side, I have cosine squared is 1 minus 9/25, which turns out to be 16/25. And then when I'm getting ready to start taking my square root, I remind myself that my angle is in quadrant 1, and in quadrant 1 cosine is positive, so that means I should be taking the positive square root. And I'll have positive square root of 16/25, which is 4/5. All right, I'm going to do a similar sort of move here for cosine of beta being 12/13. And using that to figure out what is my value for sine of beta. So again, I'm going to do the same sort of thing that I did before and say that, well, we know that sine squared beta plus cosine squared beta is 1. And I know that cosine is 12/13. So I have sine squared beta plus 144 over 169 is equal to 1. And then same as before, I'll bring that 144 over 169 to the other side. And I have sine squared beta is 1 minus that, which gives me 25 over 169. And same as before, alpha and beta, they're both in quadrant 1. In quadrant 1, everybody's positive. So I know sine of beta should be positive, which means I should be taking the positive square root. And I have root of 25, which is 5, over root of 169, which is 13. And there we go. So we've got now our values for sine and cosine and of alpha and also of beta. Now that I've got that, I can get my values for tangent. For the first one, for tangent of alpha, that's easy enough to find because that's just sine of alpha divided by cosine of alpha, which is 3/5 divided by 4/5, and 3/5 divided by 4/5 turns out to be just 3/4. And same thing for tangent of beta. I know tangent of beta is sine of beta over cosine of beta. And that would be 5/13 divided by 12/13, which is the same thing as 5/12. So all of this is really just the background work to get us to where we want to be, because the eventual thing was to find what is tangent of alpha plus beta. And to do that, I needed tangent of alpha and I needed tangent of beta, which is why I had all that sine and cosine work having to be done first. But now that I've done that, I can find my answer for tangent of alpha plus beta pretty quickly, because tangent of alpha plus beta, the formula says that that should be tangent of alpha plus tangent of beta over 1 minus tangent of alpha times tangent of beta. And easy enough to now evaluate that. So we just put in our 3/4 for tangent of alpha and our 5/12 for tangent of beta. And then just a little bit of cleaning up. Numerator simplifies to 7/6. The denominator, 1 minus that, gives me 11/16. And then 7/6 divided by 11/16 is 56 over 33. There we go. So the actual finding of tangent of alpha plus beta was just really putting things in a formula, but to get there we needed to do some chapter 7 work figuring out what was sine and cosine and using them to figure out tangent first. Of course, some other things that we can do would be establishing new identities from old. So if I'm taking a look at this identity that I want to establish, cosine of pi minus theta equaling negative cosine of theta, it's pretty clear which side to start with. I'm going to want to start with the left side because I see I've got a cosine of pi plus theta. That's something where I've got an angle sum identity for cosine that I can use. So I guess I should go ahead and use it. Cosine of one angle plus another is cosine of the first angle, cosine of the second, minus sine of the first angle, sine of the second. And now just a little bit of evaluating cosine of pi and sine of pi. So if you're remembering the graph of cosine of pi, that's -1. And if you're remembering the graph of sine of pi is 0. And then cleaning things up here, it's pretty quick. We just have -1 times cos of theta or negative cos of theta. And that second term, 0 times sine of theta, that term's gone. So we have negative cos of theta, which is our right side. So there we go, left side is equal to right side, and our identity has been established. All right, let's do another one. Again, if I'm looking at what side to choose, the left side probably feels like the better choice. And that's because I've got a sine of alpha plus beta. So at the very least, I can use that angle sum identity for sine. So why don't I do that? Sine of alpha plus beta on the top. And sine alpha, sine beta on the bottom. So using my formula for sine, it is sine of the first angle cosine of the second plus cosine of the first angle sine of the second one. And now if I'm thinking what to do next, I'm looking at the right side of my equation and I can see that there are two terms. And currently, right now, I have just one big term, one big fraction. So I'm thinking strategically it might be nice to split this into two terms. That will help me get closer to what the right side has. So instead of one big fraction all over sine alpha, sine beta, I'll make it two smaller fractions over sine alpha, sine beta. So I'll take that sine alpha cos beta and have it over sine alpha, sine beta. And then plus the second half of my numerator, cosine alpha sine beta, having it over sine alpha sine beta. And now I can see that I'm almost finished because, number one, I'm going to have a bunch of canceling. Sine alphas cancel in that first fraction, and the sine betas cancel in that second fraction. And that just leaves me cosine of beta over sine of beta, and then plus cosine of alpha over sine of alpha. And I can see what I have here. I have cosine over sine is cotangent. So what I really have here is cotangent of beta, and I've got cosine of alpha over sine of alpha. I've got cotangent of alpha. And what I've got, cotangent beta plus cotangent alpha, that's equivalent to the right side. So there we go. Left side and right side are indeed equal, and we are finished. Okay, good, good, good. So we've done some establishing identities. Let's do one other one, and this one's kind of a fun one because we'll have some inverse trig to throw in the mix. This looks worse than it is, but it's actually not bad. Remind ourselves that when I say cosine inverse of something, that is an angle, and sine inverse of something, that is an angle. So really what we're looking at is cosine of one angle plus another. And now I'm just going to go right ahead and start doing what I need to do. You have two choices. You could evaluate these inverse trig functions up front and then deal with the cosine afterwards, or you could use the cosine of one angle plus another first and then deal with the inverse trig later. I'm going to do that second approach. I'm going to actually show both approaches. So one approach would be the one that I want to do, which is to say that we've got cosine of one angle plus another. So that should be cosine of the first angle cosine of the second angle minus sine of the first angle and sine of the second angle. And now you'll notice that we've got some sines and sine inverses mixed together. We've also got some cosine and cosine inverses mixed together, and then we've got some mixing and matching going on here. So the ones that are the easy ones, we have cosine of cosine inverse of root 2 over 2. Root 2 over 2, that is something that's inside the little restricted domain. And so if I said cosine inverse of root 2 over 2 and then applying cosine to it, they should cancel each other out, leaving me just root 2 over 2. If I'm thinking about the other one, I have sine and sine inverse of root 3 over 2. Those should also cancel each other out because, again, we have root 3 over 2 is inside that little restricted domain for sine inverse from -1 to 1, so they will cancel each other out just lovely, leaving me with root 3 over 2. For the rest of it, we just have to do a bit of evaluating. So if I'm thinking about sine inverse of root 3 over 2, I'd say, well, I know what angle gives me sine a value of root 3 over 2. That is pi over 3. So cosine of sine inverse of root 3 over 2 is cosine of pi over 3. And same thing for cosine of inverse of root 2 over 2. What angle gives cosine a value of root 2 over 2? The answer is pi over 4. So we have really sine of pi over 4. And now I just have a little bit more evaluating to do and I'm finished. So I have root 2 over 2. Cosine of pi over 3 is a half. Sine of pi over 4 is root 2 over 2. And then I have the root 3 over 2. And then just cleaning things up gives me root 2 over 4 minus root 6 over 4. Or if I wanted to write it as one fraction, root 2 minus root 6 all over 4. Okay, so that's one option for how you can tackle this problem, and I think that's not a bad choice. But there's other options that exist, and so I'm going to just show us another choice that we could have done instead. So my option that I went with was to use the angle sum formula for cosine first and then deal with my inverse trig functions afterwards. If I was feeling kind of fun, I could have noticed that these inverse trig functions, I could just evaluate them pretty easy up front, and then it will be a little bit faster for me. So at the very beginning, I could have noticed for myself that cosine inverse of root 2 over 2, that's a nice angle, that's pi over 4. And that sine inverse of root 3 over 2, I could have again said, well, that's a nice angle, that's pi over 3. So really, what am I looking at? I'm just evaluating cosine of pi over 4 plus pi over 3. And now that's not a problem at all. I can just use my angle sum formula for cosine. and I'll get exactly the same answer that I did before. So it's up to you sort of how you like to do this, but that's the nice fun part about this is that um, you have actually multiple options. So we wind up with exactly the same answer as before, a root 2 over 4 minus a root 6 over 4, or root 2 minus root 6 all over 4.